Live from New York, it's Ask an Engineer!
Hey everybody, welcome
Hello.
to our new exciting back from holiday and travels Ask an Engineer. I'm Lady Ada, the engineer. With me is Tom, the Tom Igo.
Hello.
Massimo, the Massimo Banzi.
Hi.
And behind the camera, on camera control, is
Hello.
Adabot. Wave for everybody, Adabot.
Hello, how's it going?
Broadcasting from an undisclosed location.
Yeah, those aren't nicknames, you just repeated their name twice, by the way.
Oh.
Okay.
Well, we have to come up with nicknames.
You gotta work on
Maybe
that.
the quiz question will be their nicknames.
Ah, that'll be interesting.
Gotta work on that.
Best nicknames.
Okay, are you ready?
Yeah, what's on tonight's show?
On tonight's show, we're going to talk about what was on the show and tell. We have some special guests, Tom and Massimo. So you can see what's on the screen here. I have pictures of you guys. Anyways, Tom and Massimo from the Arduino team. We're going to be talking about Arduinos, a little bit about the team, Arduino past, Arduino present, Arduino future. You'll be visited by 3 Arduino ghosts.
Wow.
Why did you pick that chip? We'll answer your questions about the software, about what's coming up. We'll answer general questions, and then we'll have a trivia question. At the end of the show, we'll have a cat. All that and more on Ask an Engineer.
Not just a cat, a boss cat.
Yeah, we have a cat.
I'm
We have a
looking forward
cat
to
who's a boss.
Yeah, we have a cat. So he's going to wear this. So that's
Oh.
yeah, nice.
Super cute.
All right. Okay. All right, guys.
MOSFET.
How's it going?
Hello.
All right. Why are you both here? Why are you in town?
Well, I was here. We came here for Maker Fair. So I arrived here actually on the 11th of September. So it was an interesting day to be
Yeah.
here. And then I decided this year that I was going to be here for a month to
Wow.
experience a whole month of New York and hang out with lots of cool people like the two of you.
Actually, there's a new off-Broadway show called Arduinos.
Yeah.
Yes.
And he's doing casting calls.
Yes.
He's a director.
Email us if you want to be in
Maybe
there.
next year that would be
If you're an engineer and can sing, call us.
Yeah.
And Tom, you're always here because you're teaching.
I
Right?
live here, yes. I teach at NYU, so I'm here all the time. But the good thing about this month is that it gives Massimo and I a chance to actually finish our conversations, because it never fails that when we get together, we're together for like 3 days.
Yes.
And we just get something really going, and then, we got to get on a plane.
Yeah. And this is like the nice, not so crazy spot of the semester where the
Yes.
students are busy, but you're not like doing tons of grading and stuff.
Yeah, this is the phase where they're enthusiastic and not yet panicked.
Oh, okay, good.
And I love that phase.
Yeah, it's like office hours and they're just like crickets, and then like the week before finals, everyone's like, I never knew I could ask you for help. I'm going to be there all day.
Yeah. Oh, actually, no. They're in the office hours now, but they're in office hours and they're excited about being there. They've got questions that they're really interested in, and they don't feel like the world's going to collapse on them tomorrow. I love this time of the year.
Okay, that's good. All right, that's
Okay.
cool. Good introductions.
So we have a special discount code. We do this every week. Can you guess what the code is? It's Arduino.
Arduino!
Yeah. So 10% off everything in the Arduino category on Adafruit, which is a good deal.
All Arduino goods.
Everything 10% off.
Arduinos. And accessories.
So please pick up something.
Pick up an
Join the
Arduino.
revolution.
Join the revolution, the
If
Arduino revolution.
If you don't have one, this is a good time to pick
Yeah.
one up.
That is true.
All right, so real quick, we had the show and tell, and it was a little hectic, but the thing that stuck in my mind the most was this POV thing. Can you talk about this
Yeah.
thing, this crazy thing? Yeah, this thing was insane.
Yeah, there's the new version of the Google Plus Hangout. It's like all different now.
Yeah.
But we figured it out somehow. And yeah, the first person who showed a project, it was a TLC 5940 based mega POV. It was like this big, and it's like full color, gamma corrected. It's super cool. It reminds me a lot of many of the Ply art I've seen, so I'm excited to see this project documented online. I think he even posted a web page.
Well, and you got my curiosity up because he said he did it with common cathode.
Yeah, he's
LEDs. How did he
multiplexing
pull it
them.
off?
He's multiplexing them,
Okay.
which is totally okay, but not how I would do it. I would actually just have one per driver. But then, yeah, it's like you actually don't need to. The TLC 5940s are so fast that actually you can have, them separate into R, G, and B, and then you just multiplex them 1 to 3, and then you just save those chips are big,
Yeah.
so you get to save a lot of chips.
Fair enough. And was he just using the MOSFETs for extra current, or?
No, that was driving the anodes.
Okay.
Yeah, it was.
That makes sense.
It's a little different than how most of the time you'd see it hooked up.
Okay. Fair enough.
But it was like wicked cool, and I'm sure he has tons of good photos online. So.
I mean, just the little bit of visual I saw when we came in looked fantastic.
Yeah.
So.
Okay.
Sweet.
So let's
And
just
some breadboards too.
I know, that blew my mind. I was like, oh my god, how are you doing that?
let's get started with talking about Arduino stuff because lots of people always have questions. This will be a good time.
Okay.
So we'll get through some stuff first. So I have a photo of the entire Arduino team, the 5 of you. It's not everybody, but can you just quickly talk about who is the...
Okay. Well, the core team is made of Tom Igo, that you see here. And then there is Gianluca Martino, who is the other Italian in the team, who deals with the manufacturing and designing of the hardware, let's say. And then there is David Mellis, who is currently somewhere in Cambridge, Massachusetts, who is a PhD student at the MIT Media Lab and is also the software architect of Arduino.
He's like a Beakley student, so it's like
Yes,
there is like
exactly.
a little nucleus of Arduino there.
Yes, there's an Arduino cell that's
Yes.
operating inside the MIT Media Lab. And then we have David Quartielles, who is probably sleeping somewhere in Sweden right now, who is Spanish but teaches at the K3 University in Malmo in the south of Sweden. And then there's me, Massimo Banzi, and the 5 of us. We met in different situations, so in some different situations at this place called the Interaction Design Institute Ivrea, which is a sort of graduate school for interaction design that was in Italy that doesn't exist anymore.
It's a little bit like the Media Lab for.
Yeah.
I mean, when people talk about like interactive design grad schools, there's the Stanford Proc Design School, just pretty well known. There's ITP, which is also well known. There's the Media Lab, that's also pretty.
Yeah,
well known.
Ivrea was doing pretty well, and that's why it got shut down.
Yeah.
Because in Italy, every time you do something good, you get shut down.
Yeah.
Because you shouldn't stand out.
Right.
Like stay where
You're
you
hammered down.
Stay
Okay.
back, go back into your chest. So we met in different situations. David came as a researcher, and I started to talk to him and say, would it be cool to do something new here? And then David Mellis was a student. Gianluca was a local that was from the area of Ivrea. So whenever I had to make something, manufacture some electronics, I would call Gianluca, say, Gianluca, can you make like 10, 20 of these?
Oh, so he already had a factory, and he was making other products for other.
At the beginning, he didn't really have a factory, but he knew, one weird thing about this place, Ivrea, is in the northwest of Italy, is where this company called Olivetti used to be.
Right.
So Olivetti was making personal computers and everything. So it was famous for the typewriters, and it was almost like a small Silicon Valley because it's like full of little companies that do all sorts of electronic manufacturing and everything. So when Olivetti closed down, actually what happens is that it kind of broke down in hundreds of little companies. So you have these barns, and you open the door, and then somebody is like running like 20 pick-and-place machines like crazy. Yeah. But it's not so sort of in your face as in other parts of the world. But so Gianluca knew all of these people. So when we wanted something made, he could get the PCB that we wanted, the assembly that we wanted. So it was a natural.
That's cool.
And then Tom, I invited him to come over to Ivrea to work on a crazy project to design these interactive lamps.
Yeah, we had met through a mutual friend who was teaching at Ivrea, and Molly Steenson, who knows everybody on the planet, I think.
We had a mandate in Union Square.
Yes, we did. And it was probably listed in back page of San Francisco, and then we had kept saying, let's get together and do something project-wise.
So you were at that time teaching in ITP?
Yeah, so as it turns out, Massimo got hired at Ivrea to start the physical computing program there at the same time as I got hired.
You were like a research scientist?
I was the teacher of physical computing.
Okay, great. And you were teaching at ITP?
Yeah, and ITP had gone from being, physical computing being elective to wanting it to be part of the core course, and that's when I was hired. And so we both basically started teaching it at the same time.
Did you meet before that, or I don't understand exactly how you?
Well, what happened was that Ivrea and ITP kind of knew each other. There's a lot of common people between the boards, and I had actually applied for the same job he had applied for at Ivrea and at ITP at the same time, and ITP answered first, so I was like, well, I'll stay in New York. Okay. And also they hired him.
No harsh feelings.
I didn't know until this very moment.
Surprise! You were my competitor. No, it actually worked out very well for both of us, I think. But anyway, what happened was we kind of knew about each other all the way through, and we would correspond by email various things. And then, like I say, Molly Steenson introduced us, and we said, well, let's get together next time you're in the States. He was in San Francisco, and we met in a cafe and sort of talked about what we were doing, what we were enthusiastic about. And we both said, well, I haven't got anything right now, but when we can get together, let's do. And then finally the chance came right as Ivrea was closing for me to go over to do a workshop with them to design some lamps. And that's where it all started.
Okay, so we're going to back up just like 6 months before then.
Mm-hmm.
So you were at Ivrea, and did you get hired at Ivrea and you had this idea for developing a prototyping platform, or was that something that you did after you got this job and you're like, I need to make it?
Is this part of Arduino Pass? Because I have a graphic.
Yeah, this is Arduino Pass.
Okay, whoa, Arduino Pass.
We're already like way in the past.
Okay. Well, that was Arduino team intro. Okay, Arduino Pass.
And Pass.
Well, yeah, in my case, I had just quit the job working in a venture capital fund. I sort of realized it was not my life, really. And I started to work at this place to help people, to help the students. And so they hired me then to be a teacher. And then I realized that, we were using basic stamps. And then, the more we were using them to teach, it was really sort of painful because they were very limited. They were running on Windows. We didn't really like them very much. So we started to use the BX24s because we were cloning whatever Tom was doing in the US.
So wait, the BX24, just to remind me, is that like a basic stamp type thing?
It was like the basic stamp. It was actually running the Atmega 8535, and they were running a version of Visual Basic on it.
Okay.
And unlike the basic stamp, which is entirely interpreted, they were actually compiling and then downloading to it.
Yeah. So also the problem is that they were dying like there's no tomorrow. You made like a stupid mistake and the chip would die.
The early AVRs were not. I mean, they're pretty solid now, but I do remember that
they weren't friendly.
They were very fragile.
Early FTDI chips and early AVRs, like they actually would die from ESD. I mean, like I'm better at doing ESD protection now, but.
Yeah.
Frazzle. Okay.
So what happened then is that I realized this was not going to go on. We couldn't go on like that. So I started to make a lot of prototypes of different prototyping platforms. Originally with the PIC chips, because in Italy the PIC chips were very cheap because they were used to hack satellite receivers.
Right.
So people used them to hack the sort of satellite to watch the football. So you could buy them all over the place for like a couple of euros. So I started with that, and I made my own platform called the Programma 2003, which is essentially had the same kind of some of the features of Arduino. So like a simple IDE with only a few buttons, and had like it didn't use C, but it was another funky language, but it was open source, it was cloud platform, and then you just press a button and it downloaded the code. So we had sort of the user experience figured out and the whole sort of way the platform should look like figured out, but the PICs were just very limited and the language that we were using wasn't really good. It was good, but it was very limited. Cool. So
were there any other platforms that you wanted to use? Because at the time, this is like 2003 or so?
Yeah.
So around that time, there were a couple of prototyping platforms. Why didn't you choose any of the other ones? You just wanted to make your own? Or?
Well, also one of the issues that I wanted is that one of the limitations of the basic stamp is that back in that time, the import of the basic stamp into Italy was kind of weird. So you ended up paying about $100 for one basic stamp. So clearly,
they're like 60. The high end ones are $60.
Yeah, but if you add all the taxes and all the sort of other markups along the chain, it was $100. And clearly, students don't buy more than one.
Yeah, and for us at ITP, at that point we just started to switch over to the PIC for that exact reason, because students didn't buy more than one, and because I wanted them to understand that physical computing didn't mean a computer. You could have multiple processors in one project. The problem was that meant introducing them to a programmer, to PIC Basic, which is very, very limited, to making the whole circuit, and for brand new beginners, it was just a total pain in the butt. And I remember one conversation actually with you and Casey via email about the Javelin stamp. So Casey Reese was part of this whole discussion because he was teaching at Ivrea at the time, and he was doing processing, and processing was all in Java. So he said, well, wouldn't it be great if there was a Java microcontroller? And Parallax had the Javelin stamp at that point. And I remember him mailing and saying, Tom, what do you think of this? And I looked at it, and I wrote back and I said, seems a little too complicated. And he opened up the Javelin stamp Blink example, and he wrote back to me and just went, I'm scared. And that was the end of that discussion, I think.
Yeah.
But the price thing was a big issue, because we did, I think, in both sides of the Atlantic, we both wanted to get the price lower than $50.
Yeah, for us it was good because you could just take out the chip, from this program Adafruit 3, and you could just plug it into your breadboard, so you could do a lot of things. So in a way, all the elements of what ended up in Arduino were already there. So we had a bootloader, we had a prototyping board that students could assemble themselves, and then we had this IDE that I hacked together that was a bit similar.
And you had Casey help you out.
Then yeah, when Casey was next to me in the office, so we started to discuss, and we said, okay, wouldn't it be great to have a project where you basically had like processing running on hardware? So there was a lot of discussion inside the faculty about that. And then essentially there was a student, Hernando Barragan, who did a thesis project based on this concept of trying to take processing running on microcontrollers. So there was a number of sort of direction that were taken, but in the end, one of the people that was very influential in sort of in my understanding of physical computing, Bill Verplank, who teaches at Stanford, told me you should just use these AVR processors. They are very, it's very simple. There's like an open source C compiler, and it would be very easy for you to make something that looks like processing, just by sort of hiding away the C, so the includes and everything else. You could make it look a bit like processing, and then it would just work. So we said, okay. So then in the thesis project, they took that direction, and then we came up with a wiring board. But then still at that point, the wiring board was running on this Atimega 128, so it was kind of expensive and big, and I wanted something much smaller, and I wanted something open source, and that's when magically, David Mellis was my student, and then David Quartiers came over to be a visiting researcher. David always tells the story that I put him in a basement with no heating for 2 weeks, just to test if he was a good guy.
Which is probably true.
We still put him in a basement. Yeah.
So after two weeks of like trying him out in the cold, so we decided to kind of work together, taking what was done in wiring that wasn't open source at the time, and sort of re-implement it completely as open source. And then we had this idea of making it also open source hardware. So that was also one other sort of decision that we had at some point.
What's interesting is how processing comes into it, because I knew of processing because it germinated in the Media Lab, and I kind of...
You guys overlapped at...
Yeah, we did overlap a little bit. I remember Casey Rees, and it's interesting because processing was this superset of this thing called design by numbers, which totally didn't make it, but processing just completely took over. And I remember people before then who wanted to do any graphical work was like, okay, get OpenGL, learn C++, and then it's just like a nightmare, and then processing came up, and it was suddenly the easiest thing in the world to do anything you wanted to do with graphics. They got expanded, and I've tinkered a little bit with processing, and I think actually it's not as easy to use as Arduino. Maybe it's just because I'm not a graphics person, and also because it's a bigger system, honestly. But it's interesting that processing revolutionized, graphic art and animated art for anybody who wasn't like like working in a 3D shop, and then that kind of filtered into Arduino, which worked really well.
One of the things that Casey and Ben did that we really tried to emulate was that they wrote good, fairly simple examples. And I think the one thing that always, the only frustration I ever hit early on with processing was that I'd have students ask me about various variables, what is this I thing, or what is this C thing? So, I think the only thing we tried to add to what they were doing in terms of example style was to use full words. But they were really good at making the example simple, making an example do one thing, and commenting the hell out of it. So that you really understood what it was doing, and I think that helped it build a lot, and we've benefited from learning that from them.
Also the development environment was incredibly simple. There was only the exact number of functions that you need in order to get started.
Still is.
And I think that's one of the advantages, is that you turn it on, and as a beginner you look at it and there's only like 6 or 7 buttons, and then when you see only 6 or 7 buttons,
there's no like menus, no preferences,
well,
no
there are
like
menus, but they're not that much.
Yeah, but there isn't like, I can collapse this frame and then like all your files are there.
There's not like, okay, let's click on the Java view, and then suddenly all the screens start to move, and you get another toolbar, and the toolbar buttons unroll other buttons. it's like, oh my God, what's this? So in a way, I love the incredible simplicity of and we actually had to be sort of thankful to processing, because we actually sort of at the beginning, I think we sort of connected with the processing community. So a bunch of the people that were doing processing, they were doing art, and with processing, essentially they started to use Arduino because it was they could transfer that knowledge, and that's also was one of the original ideas that we had, that we didn't want the students to have to say start learning programming with, I don't know, Python, and then the next month they have to learn BASIC to be able to run on a chip. So you waste so much energy, and with this interaction design students, you have so little time. You have 1 month to teach them something, and the next month they're doing something else. So you don't want them to.
And you have to give them enough so that they feel comfortable exploring other weird parts.
Yeah, and actually that's a big thing with them, with the students we were teaching. They didn't want to be programmers. They just wanted to get shit done. Excuse my language. And I think that was something that took a bit of getting used to. But once we did, we went, aha, okay, if you can pull that off, it's a powerful thing for other people.
I think that became sort of generically also one of the principles behind Arduino. I think that Arduino is used by people who want to make things. So they don't really care about what tool they use, as long as it gets them where they want to be.
Yeah.
And this is sort of in contrast with like the classic engineering principles, where engineers are very concerned about what tools they use. They have long debates about what tool to use. While the kind of Arduino user that we deal with is somebody that they don't care if they use a hammer or they use a chainsaw. They just want to make something, and they will use whatever tool gets them there fast.
What I think is great about Arduino, personally, is that when I was in school and like I was at the Media Lab, I was the one engineer sort of in that area, the EE in that area, because I was the only person who actually graduated through the MIT EE program. And so I would have students constantly come in and just ask, like, I just want to have when I press the button and the person's nearby, the LED goes off and it plays a sound. And I was like, like, leave me alone, I got my thesis to do. And I would, I'd actually end up helping people with their projects, but I kept doing the same project over and over again. Get the microcontroller on the board, you lay out the board. It was just, it was very frustrating.
Yeah.
And they never learned anything because I never had time to teach them because I was busy just getting their project to work. And now, you would just say, just get an Arduino and like Google for this example, and like almost everything's already been done, which some people would say means Arduino isn't creative or challenging, but I think it actually means it's extremely creative, because that means you're no longer banging your head against the wall asking why isn't my UART work, or like why is my LED blinking 8 times slower than it ought to be, or like my delay loop doesn't work because it's got optimized or whatever. All that bullshit got taken care of. Instead, they can focus on the final thing they want to do.
Yeah.
So that's why you see people who are very beginners. They're like, my first project, and it's just like this massive engineering contraption, which is really neat.
Yeah. Well, actually, related to that, like, I'm gotten used to the point now that I can get people up to going pretty fast. But with the first project my students are supposed to do 3 weeks into the class, it's supposed to be a basic sensors plus LEDs plus sound kind of thing at most, right? So I probably had 7 or 8 people at least this week, they're due next week, say to me, well, this is all great, but I can't get this sound shield to work yet. I'm like, you're not supposed to be doing the sound shield yet. But they are, because they can.
It's there.
And at first I was like, oh, they shouldn't be doing that. But now I'm going, no, actually they should be doing that. They should be pushing that further and further to the point where they're getting to the thing they want to do. Doesn't matter if they're getting all the details.
Yeah. I like this idea that, in a way, the way Arduino works right now, you actually you build something using the tools that you find, so you basically quickly get to a certain point, and then if you want to understand how this whole thing works, you just go back and you can drill down. You can say, okay, now I'm going to see what's inside Arduino. Then I get to see the C code and the C++ code. And if I really, really want to, I press Shift when I'm compiling, and I can even see the assembly language that gets generated by the code that I do. No? So, and I think this was a reaction to the way I had to go through. I studied, but I never finished studying electrical engineering, and it was driving me crazy the first year that you had to sit in class and there would be somebody talking for hours and hours and hours about very basic things. So everything was like a big build-up. You had to wait for like 3-4 years before you could build something. And that was completely the opposite for the high school I went through, where you actually spend the time building stuff.
Yeah.
So in the end, I said, I don't want people to sit down and have to learn theory for 1 year before they can blink an LED. I want them to blink an LED and then kind of start peeling all the layers and start to understand all the layers.
I think like Ohm's law should be like the last thing you learn.
Yeah.
I mean, for people who are not training to be like true electrical engineers, if you just want to build stuff, you leave the equations till the end.
Mm-hmm.
So this is why I think it's interesting. People used to say like, oh, you want to learn electrical engineering? Okay, pick up a copy of Horowitz and Hill and just open up to page 1 and read through. And it's good for a classical engineer, but terrible for anyone who wants to actually do anything.
Yeah.
Instead, you can just say get an Arduino and then do your project.
Okay, I'm going to be time cop. We're at the halfway point of the show.
Right. So we kind of introduced the
That's
Arduino.
nice.
So
Arduino Vast. I just want to add one thing. The fact that it was cross-platform was great for designers.
Yeah.
Right.
By the way.
Especially given that I've got 99%
For us,
Mac
the fact
users.
that it would work properly on Mac was very important.
You got interesting designers and people who normally would not be able to program microcontrollers. Crazy stuff.
Do people have any questions?
They do, but let's not do the questions
You
yet.
have questions?
No, I want to get just some more data out there. Yeah, some Arduino present. So, okay, great. Lots of cool past. You guys did some neat stuff. You met in a basement or something. I don't know. Arduino present. Can you talk about what's currently out and how many Arduinos out there? Because I always get asked this, and I just wait for you to tweet it.
And all the different kinds of Arduinos there are.
Yeah.
Well, at Maker Faire, I said that if we look at the Arduino Uno sort of type model and all the models...
The classic.
The classic, let's put it this way, yes, the classic. If you look at the classic, basically there are about 314,000 classic Arduinos out there.
So that includes the original, the NG, 10.000.
Yeah, the 1009 and the Uno,
And the Uno,
R1,
the
R2,
okay.
and the upcoming R3.
Wow.
So sometime next year there's a chance, or the year after certainly, that there'll be 1 million Arduinos.
It's definitely possible, because if you look at the curve, it just goes tuck, 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 and in the last year it just went. I mean, we already are at like 100,000 Arduinos sold between January and say August, and in the whole of 2008 there were 80,000.
Yeah.
So clearly the curve is becoming vertical.
Yeah.
So
We should start an online site.
So probably by the end
that'll predict because you'll know which the millionth one is.
Can I hijack that
Actually, that's a
counter
good
they
idea.
have here in Union Square and just like...
Yeah, no one knows what it does, so you can totally do that.
We'll change it to blue LEDs.
Yeah.
So it'll be probably 500,000 by the end of this year, and then maybe next year you could have another altogether, including the Mega and the Ethernet and all that stuff. Maybe
Yeah, the fact that now Arduino will be distributed by Radio Shack has given another further push.
Congratulations.
Thank you, and thank you for making the introductions on some of that too.
I was one of many people that kept saying Radio Shack, if you want to get back in, you have to go with Arduino, and they have 6,000 stores in the U.S.
Yeah.
Incredible.
But we had a meeting at Maker Faire, and I have to say that the people I met were fantastic, and they have their hearts in the right place, and they really, really believe in like getting back into the sort of maker spirit and providing people with the tools, the equipment. So it was very nice to have a meeting with these people and to understand that they don't want to become, to be again a mobile phone store, but they.
Okay, so can you talk about the current lineup of Arduinos and then what you announced at Maker Faire? Because I consider that like Arduino present, sort of.
Sure. So what have we got in terms of models? Right. I always forget all the models we've got, so Massimo's going to yell at me. We have the Uno. We have the Mega.
2560.
We have the Mega 2560. We have the
Nano and
Nano, the LilyPad Arduino, the FIO. We have the just announced Arduino Ethernet.
We introduced recently the Ethernet and the 80K.
And the 80K, which is Mega 80K.
The one designed originally by Google.
Yeah. Those are all the actual board models that are named Arduino, I think. Right?
There's also a few Arduino Pros that are made by Spark.
Oh yeah, there's the Arduino Pro and the Pro Mini. I forgot about those.
So it's like 10.
Yeah.
10 models.
And then you've got the new ones that you just announced.
Right.
Which are...
And then...
There's the upcoming Arduino Leonardo,
I love that one.
which is based on the Atimega 32U4. So native USB, single chip SMD solution, should be very cheap. Will probably be sold without header, so it's probably going to be like a very simple building block that you can sort of, use in your projects. But since it has the USB on board, you can also enjoy the fact that you can emulate the keyboard, the mouse, the MIDI will come at some point. So there's a lot of these features that are interesting. We have already have introduced it at the previous Maker Faire, but we are working on this Wi-Fi shield, which is one of the things I like a lot, because we sort of, instead of using the standard Wi-Fi modules that everybody uses, we actually, since we like to get ourselves in trouble all the time, we just use like a simple basic Wi-Fi sort of radio module connected to an AVR32 processor, which runs the whole TCP/IP stack and all the sort of access, the WPA supplicant and everything else, all the things you need to be on Wi-Fi and the encryption, they're all implemented as an open source library inside the AVR32. Because this Swedish company, H&D Wireless, basically provides the whole stack, which is open source.
And they sell the wireless transmitter chip.
Yeah, they sell the transmitter chip, and they give it like the open source everything. And like on Linux, there's like a small binary that you need to download into the chip in order to start it. But like a lot of Linux drivers are this, like they're open source, and then you have a small binary.
Just the register connect, the lowest level.
Yeah, the very lowest level is a binary file that you just set as a configuration, I guess. You load it, and it's nice because if you know how to program in C and you're sort of proficient, you can actually look at the source code. It compiles with GCC, so you can add your own protocols. But also the nice thing is that this board has got a USB plug, so you can actually update the firmware on the field yourself. But if you really want to, you can just remove the Arduino completely, power it by itself, and it becomes almost like a self-sufficient Wi-Fi device, if you know how to program it.
Yeah, I'm actually kind of excited about the Wi-Fi, because I actually have one of every single kind of Wi-Fi module out there, and I've used them all. And they all suck in different ways.
Yes.
Which is kind of fascinating. Like one needs an NDA, and one uses a really weird protocol, and one doesn't support like most Ethernet, most bridge devices. Yeah. And one doesn't do the most common encryption. So it's like a kind of a nightmare, because I actually have like shields for each one, or breakout boards for each one, and like none of them really felt like they were good enough to release. They were all just kind of like crummy.
One of the things I've actually liked about working with this one, I deal with the university IT system, and I probably can leave it at that, but to go a little further, they tend to be somewhat, shall we say, concerned about security. And so I've spent the last really 10 years fighting with them about getting anything on the Wi-Fi network that they could not identify as an operating system they understood, right? And they'd say to me, well, that thing you just attached to the network, we did a port scan on it, and all the ports are open. I'm like, yeah, but they're not attached to anything. Yeah. So they would freak out about this. And they made it very difficult for me to get any Wi-Fi device on. This one, I've been able to get on just like that. And it's been nice and stable. I mean, we've had development work to do in terms of the API, but the connection just works.
That's sweet. Is this hammered out? Is it going to be using an AT style interface or SPI?
No, it's going to be using an interface very much like the current Ethernet library that we've got out there. Great. And what's great about it is it's really only one line of change.
I like that, because I like the AT style interfaces, but they're using a UART. I mean, like for an Arduino, UARTs are so hard to come by. Yeah. And of course, if you have Wi-Fi, you'll also want like a GPS module or something else that uses UARTs. This is really nice. You can
it's using an SPI bus on it.
In this case, what's nice is that we move the base classes that identify a client, server, an IP address, and this kind of stuff into the core of Arduino. So basically now, whenever you want to develop a network-related library in Arduino, you can derive from these sort of basic abstract classes in the Arduino language. So basically the new Ethernet library and the Wi-Fi library derive from this. So as Tom said, you just change a couple of lines, you can port your code from Ethernet to Wi-Fi, and other people will be able to make their own libraries more compliant if they want to.
Yeah,
And also the communication between the Arduino and the thing on, so the shield on top is happening through SPI, but these two nice developers we work with, Mimo and Claudio, they basically made this very simple library that basically lets you plug more commands. So essentially it's almost like a remote procedure call happening on SPI. So we think that maybe that protocol could be used in the future to interface more SPI devices.
Okay.
Yeah.
I love SPI.
Yeah, some of the change on this too came about because I was working on getting an example of it into Making Things Talk, and I had one page of text to explain the Wi-Fi stuff, and I was like, all right, guys, the interface has to be close enough to the Ethernet module that I can do it in one page. And God bless them, they actually pulled that off, so I was really happy about that.
Okay, cool.
Okay, and
That's
so
exciting.
next up, let's do a little bit of Arduino Future. There's some new releases coming up soon, and then there's also, you have a new prototype area, right?
Yeah, well, there are two major things happening. Like, one is that by the end of October, we should have the release of Arduino 1.0.
Yeah.
So in a way, this is something that we wanted to have, because in a way, okay, we broke a few APIs, but in
I brought this up before.
yes. She just watches us and tells us.
I like how everyone was like, I don't know what you're talking about. And then the developer list explodes with people being like, I can't believe you broke everything. I was like the first person to try it.
We broke something in order not to break it anymore.
Yeah.
So the idea is that once you have a stable API, then it's easy for people to write books, to write tutorials, because you can say, okay, this is compliant with Arduino 1.0. And that's something that to me is quite important. I was very attached to this idea of going 1.0, freezing all the API, so that we can start thinking about the future. And the future is this Arduino Duo that we sort of talked about at Maker Faire. So we developed this board based on this 32-bit ARM processor, the SUM3U4.
Also made by Atmel.
Yeah, it's another Atmel product. And then we had some help by some great Atmel engineers to sort of transfer the Arduino code so that they can run on this beast, which is quite different. But also it was quite nice. What was nice actually that I also got a call from the people at ARM in England, the one who sort of licensed the core, who was also very excited about the idea of Arduino running on ARM. So they are also helping now to add cool things to Arduino that you can do, because this processor, for example, has a number of instructions that can implement some of the basic operation of a DSP. So they are making a library that you could use to do DSP operations on the Arduino. The peripherals are very high performance. The USB is like full speed USB. So it is an interesting object, and in a way it is completely different from the basic AVR products that we use right now. So it is a place where you can start thinking about new scenarios. What happens when you have that much power, that much functionality.
It's great to see the chip makers become very interested in Arduino.
Oh, yeah.
That's fantastic.
Yeah.
I mean, that's like that's new and interesting.
Yeah, I mean, Atmel's been actually very pleasant to work with so far, I think. And Massimo and Gianluca have done all the work on it, but...
Yeah, we tried multiple times for like a year and a half to get in touch with them, but it was impossible. Nobody would ever reply to an email. And then at some point, a very, very nice engineer from Atmel in Norway, Christian Höhle, hello Christian, actually emailed me and said, oh, you guys are doing a great work. Oh, an Atmel guy. Yeah. So we jumped on him. And no, he was super nice. He sent us like a metric cube of equipment to play with. And then we organized a meeting to go to Norway and meet with the people who invented the AVR, Alf and Vega. And so we explained to them about Arduino.
It's
and
like
they
a missing third person in Rolf or something.
Probably.
R is risk. So the legend says that AVR means Alf and Vega risk. That's one of the many
Alf and
legends.
Vega's risk. Okay.
So the idea is that, so we went there, we had a meeting, we were there for one day in Norway, freezing cold, lots of snow and everything. But then we explained to them Arduino and they knew about it already. They liked it a lot, so they gave us a lot of help in a way. So it was nice. So, and now after the Maker Faire, they're even more excited.
That's great.
Yeah.
All right, so fantastic. We have 20 minutes of the show left about, and let's just open it up to questions.
Okay.
Yeah, so your questions to the Arduino team. The first one was a comment. Tom, I have your book. I love it.
Thank you very much.
Yeah. That's good. Okay, I want to sample a binary source very fast. What's the best way to sample it? How fast can Arduino sample digital pins?
You can, if you want to sample digital pins really fast, you can do that. The example you should look at is my IR infrared reader tutorial, because that does fairly high-speed sampling by turning off the interrupt, so you can get very precise bit timing. So you should check that out.
Okay, there's going to be a lot. We're going to go through these fast. Okay, does your Wi-Fi Arduino Shield or Wi-Fi Arduino do 802.11n? If not, do you plan one?
I don't think it does N yet.
It probably does A, B, and G.
Yeah, it basically does.
Yeah.
N is very, very new. It's still actually under discussion.
It operates at 2.4 gigahertz, so I guess it doesn't do N.
No, N is 2.4, isn't it? Oh, is it?
N is 5.8.
Oh, okay. Yeah, it's probably fixed because of the antenna.
Yeah.
Okay, next up.
But you can't really push that much data through an Arduino anyway, so
Exactly,
having N is not.
Next up, Teensy Arduino has USB MIDI support. Will the official 32U4 Arduino also support USB MIDI?
We do plan to do that.
MIDI.
Yes, it is planned.
Okay, great. Next up, major changes in the 1.0 IDE. What are they?
Cute colors.
Yeah, one of the biggest changes actually for most beginners is the shift in how you send out serial. It used to be that if you wanted to send out a raw byte, a binary byte, you had to do print the value, comma, byte. Now we just said if you want to send a raw byte, you send print. You do write instead of print to try and make that a little clearer. That's a biggie.
The IDE. You meant the IDE or
yeah,
the IDE?
Oh, the IDE. There's
cute colors.
Yeah, cute colors.
Cute icons.
We changed the icons.
Massimo likes the colors the best.
Yes,
I can tell who picked the colors.
Yeah. We changed the preferences so that for people who want to be able to see the verbose output from the compiler or the uploader, they can. We made it so that it's...
you can see the type of board you're uploading to and the name of the port at the bottom of the screen.
Yeah, that's
nice.
a biggie. We made it so that you can hold down Shift and automatically use a programmer rather than from the serial. Some people ask for that.
Does it do the automatic COM port reopening that was discussed? Is that in or not? I think it made it in.
Don't know if it made it in. I know that it closes the screen automatically and it doesn't crash as bad on the serial port as it used to. So that's been fixed.
That's good. It's been crashing bad.
Yeah, I mean, I've tried to crash the serial port several times this week.
I2C is completely different.
Yeah, I2C
So
is totally different.
things that I noticed were not the cute colors, because I was freaking out, because I2C is totally not working anymore.
But that's not the
IDE.
that's the core.
You're an API land. Yeah.
Well, yeah, but it's included with 1.0. I mean, I can't change the core.
I know, but I think actually, and that actually gets to an important point. One of the things we tried to do was use the stream library in a lot of the things that used read and write, including the wire library, which does I2C, and a few others as well.
Yeah.
So we're trying to get to the point where it's useful, that'll show up in a lot of places.
Okay, we got a ton more questions. Oh my gosh. You guys have to talk fast tonight. Okay, what happened to the verbose compile in Arduino RC1? Is it hidden, enabled somewhere?
Still there. Go to the preference menu, hit the checkbox for it.
All right. Will you release an Arduino API to load code onto an Arduino through other programs?
We haven't planned that as the moment.
All right.
You can use AVRD though.
Sure.
Yeah, but there's a bunch of, if you look at OptiLoader by this Arduino user called WestFW, he shows you how to use an Arduino sketch to take an hex file and load it into another Arduino.
Oh, that's nice.
So.
Okay. Next up, for the Leonardo, how will the Mega 32U4 pins map to the shield headers?
How are they mapped to the shield headers? The pin numbers will still refer to the same pins as they do with the Uno. So, for example, when you refer to pins 1 through 13 digital, you'll get that. I can't remember what the port numbers are.
So there was a lot of work done in order to make sure that the pinout of the Leonardo is as similar as possible to the Uno.
Yeah, there is a change with serial on that, though. I believe we actually mapped the two 0 and 1 serial pins to a different set of 0 and 1s.
No, the question is that, well, okay, the problem is that now you have a virtual serial port, which is the one that goes through the USB connection to the computer, and you have an actual hardware serial port on the processor, which is still on 1 and 0.
Yeah.
But then this means that you have a hardware serial port on 0 and 1 that you can use to talk to a device, and then you have this sort of virtual serial port that talks back to the computer. So you have more possibilities, but clearly there could be some confusion because you do serial.print.
But the basic digital and analog pins should function the same way as they do on
There
the
probably will be some shields that don't work just because the SPI or I2C or PWM pins are not going to be identical.
From the introduction of for the last year, more or less,
with the
we basically specified that the SPI pins are on the 6-pin ICSP connector.
Yeah.
So if the shield is following the same rules as our Ethernet shield, it will work. No problem.
Which one of them do? Okay, next question.
Do you have any plans for official ID support for the AT Tinies?
No.
Okay.
Yeah, I don't think so.
There you go. Yeah. I like these.
Too much pain.
I like these yes or no answers. Okay. Are the shield headers compatible with existing shields? I think you just answered.
They answered that.
Yeah. All right. Next up, how much will the Leonardo cost?
Oof. I don't have price.
I just say it's not out yet, so don't ask.
That's a good answer.
Well, it's not out yet, but it will probably be cheaper than the Uno. I don't know. We haven't figured it out exactly.
It's not out yet, so don't ask.
Yeah. Next up, if someone makes a derivative and wants to support the Arduino or make an item that's an official Arduino, do they still have to? What are the steps that they have to do to have that happen? So if they want to make an official Arduino,
those rules still haven't changed.
Yeah, it's on the site in the FAQ.
It's on the site in the FAQ.
The idea is that we tend to be very picky about what can become an official Arduino board, because you have to imagine that I would say every other day I get an email by somebody who has made the new fantastic Arduino that must be an official Arduino. And, you know, there's like 6 billion people on the planet, and probably 1 billion of them have their own perfect Arduino idea. So we are very...
The thing about open source hardware, though, is that they can go and...
Yeah, they can do it and call it whatever they want.
Yeah,
as
we're
long
pretty
as it's
liberal
not...
with derivatives. I mean, there's plenty of derivatives out there, and we're happy to see those because they add new features, they bring new things into it. But the things that we call official Arduinos, we expect that those manufacturers are going to be working at the same standards as we are, and dealing with the same kind of arguments we have with each other, which, as you know, can be a challenge. So
well, you guys have your handfuls right now with the Leonardo and the Due.
Yeah, exactly.
So you're already pretty small.
Okay, still got a bunch more questions to go. Is the Due 5-volt tolerant? How is that achieved?
I'm glad you asked.
The processor is running at 3 volts. The new sort of layout that we have will be introducing with the Leonardo and the other boards has basically a way for the shields to understand what kind of voltage is used by the underlying microcontroller. So the idea is that the shields that will be sort of Due compliant, they will know automatically how to configure themselves if they're running on an Uno or a Due or a Leonardo. So
they'll have an I/O reference.
But the problem is that the microcontroller is running at 3 volts. And if we were to make every single pin 5-volt compliant, then it would become the board would become incredibly busy. So,
all right. Will you ever consider putting an extra set of 0.1-inch line headers on any official board?
No.
Okay. No.
It will make the design.
Ding, that's my
Ding.
Okay.
7 to go.
I know. 6.
No, it will make the board really ugly.
Yeah. It would look like all those ugly dev boards that are like in the closet right now. Like there's like a million different. Yeah. Anyways, will libraries with custom AVR code work on the Due, or they have to be converted to Arduino core code?
Well, it depends on the library. Clearly, some libraries that use only the Arduino API, they should work out of the box. Clearly, there are some libraries that go really, really, really low level, and they basically touch individual registers of the Arduino. Those ones will have to be converted, but also because, for example, if you write some code that runs on the ARM processor that runs on the Due, you wouldn't even be able to port it on another ARM processor.
Yeah, it's our goal to make the libraries as compatible as possible, but we're going to an entirely different architecture. So it's really early for us to be able to tell how compliant everything will be.
All right. Next up, does the bootloader need to be modified to support USB bootloading? Does that mean you can bootload USB with other Atmel chips?
It's a different bootloader than the Uno has a different bootloader than the Leonardo, doesn't it?
Yeah, it's totally different.
Mhm.
Leonardo has a USB-based one.
Right.
Yeah, but still the idea is that the Leonardo shows up as a serial port and there's like an SDK something.
Okay. What is the ADC resolution on the new boards?
Only 10 bits.
The Due is 12 bits,
Yeah.
and then I don't know off the top of my head because I haven't prepared the datasheet yet, but I know that there's like a couple of channels where like they can go up to 1 megabit, 1 mega samples a second, and
Yeah.
Yeah. They usually have. I think some of the higher end DVRs they have like a low level. What's it called? The data transfer DMA. They have
Yep.
a DMA, so you can do like very high speed, low bit, so like 8 bit or something. I think the X Megas I think do. They can
If I
do
recall,
the
though, that
sample.
it's not all 16 of the ADCs that do that. It's only like half of them or something like that, right?
Yeah, it's usually. I mean, sometimes they have actually 2 ADCs, so you can actually do 2 samples. But every ARM is totally different. There's no standard for that.
Right.
That's a peripheral, chip by chip peripheral. We can check out the data sheet.
Yeah, best way to know is to actually look at that particular chip, which we mentioned earlier.
look at the datasheet for the SAM3U. The processor we're using is thicker than the Bible. So it's,
All right, next up,
Probably
any
not
plans for
really.
something like the FPGA Core Arduino or something like it? FGV.
Not at this stage, but you never know what the future might hold.
Yeah.
I think you can use like the game Arduino and just plug it in and
Yeah,
go to
exactly.
town.
I mean, I think there's so many people starting to do interesting FPGA peripherals to what we're doing that there's not a rush for us to do it just yet.
Yeah.
Okay, here's some fast
I mean,
ones.
also FPGAs are incredibly expensive, so it doesn't make sense to replace a very nicely working chip that you can get manufactured by the tens of thousands with an individual crafted $100 FPGA.
Yeah.
How many IOs on the Due?
57,
at the moment, it's got the same number of IOs as the Mega, so that would mean something like 85 pins,
No, it's 57. I think is what we've got on there.
57 usable pins.
Okay. Is there SSL support on the Ethernet shield?
No, that's done, but that's not done on the TCP/IP stack.
No.
That's an application layer.
Okay. Are the through-hole parts on the Arduino hand soldered?
Through-hole
No.
pizza on the Arduino. No.
Okay.
They go through a wave
No.
soldering machine,
Yeah.
right?
There's
So they're placed by hand, but then they go through a machine that it solders them all at once.
Yep.
Kinda
Yeah.
neat.
Okay.
I love watching.
Someone's thinking about making an expander shield. What type of microchip should they use if they want to use 3-pin and link to other chips so they can expand it?
Use 3-pin and link to other chips so that they can expand
well,
it.
the shift register, like the 74HC595,
Or that new high.
it has
the
3
one you just
pins in
released,
a way,
what was
and
it?
you can daisy chain them like there's no tomorrow.
Yeah. But Lemoore actually just started selling a really nice high current version of the 595.
Oh no, the T-Pick. But if you want to do IO expansion, I have a library for the MCP23008, which
Oh,
does full input/output, pull-up, no pull-up expansion. They have I2C versions, SPI versions, but they're big chips, but they do work. They're very cheap.
What she said.
Okay. And
the
almost the last
2309.
one. Almost the last question. You guys are doing
16.
great. When will Arduino Labs go live?
Well, at the moment, Arduino Labs is live. The only thing is there are only 2 projects in there because we are still working on it. One of the things that one thing that is going to be cleaned up right now is the whole section about the ADK border. We did a lot of work trying to sort of fix all the problems that were in the example code, and David went to this conference called Over the Air in England, and so the whole conference helped him fix the code.
Awesome.
So
I think we got a couple months till actual launch though, because we're kind of tinkering with it live with places like Over the Air and things like that as a chance to knock the bugs out with the community.
But Labs essentially is a platform where we say, this is something we're working on, it's not finished, it doesn't work, but we're showing it to you so that you can give us feedback. And in certain situations, we have engineered that wiki so that we can basically open up parts of the wiki to some users on the Arduino community to kind of come in and edit with us.
Okay. That was it.
Great.
Whoa.
I'm cutting the questions off. This is great. You guys did fantastic. We have some giveaways and a couple last things to do. All right. So, congratulations. You guys did speed round.
Thanks.
That was nice. All right. Okay, it's trivia question time.
Mm-hmm.
Trivia question. Do the rules.
The rules are If you're our friend and you're not in this room, or even if you are in this room, you can't enter this contest. If you've won a fabulous prize from us already, please don't enter this contest, no matter how tempting it is, so that everybody gets to win a prize.
Okay. What are the prizes tonight?
The prize today is you get an Uno, a Mega, and an Ethernet Arduino.
It's a big deal.
You get a
Nice.
3-pack of the 3 Arduinos that we carry. And
This is going to be
for the first person with the correct answer is the winner. So
this
don't
is
argue.
going to be a tough one, though.
This is a toughie.
Yeah.
Should I hold?
Yeah. So you want to ask the question?
Yeah.
Okay. This isn't our original Arduino.
This is an original Arduino. What are the 4 names that are right where my finger is?
Oh.
The 4 names on there on an original
That
Arduino.
one is a piece of
You
archaeology.
know what it
Yeah, I
is.
know, but I want to look anyway. 'Cause I-
It's a piece of archaeology.
4 names on there. What are they?
This is one of the first.
Put them in the chat. You
That
will
is.
win a fabulous prize.
Yeah.
Nice.
So
Of 3 Arduinos.
who has a original Arduino?
Grab your original Arduino. Well, original assembled Arduino.
Yes, this is one of the first 200 assembled we made.
Yeah. No, I remember.
Okay.
That was supposed to go to the Computer History Museum.
It was about to, but it's not.
Luckily, these things are very solid.
Yeah.
Here,
It's okay.
I'll hold this up.
Okay.
This has the original Berlioz,
Yeah.
which is
yes.
not even up
there's-
anymore. They're
there's
shutting
4
down.
names.
Just shut down
If
now.
people search around on the web, are there any photos of this original one, you think?
Yes.
Okay.
This is
so-
running an Atmega 8.
Yeah, I remember buying like 80 of those boards from you guys for my students to assemble by hand. And excuse me, since none of my students could do surface mount at all, I had to hand solder all 80 of the
Oh no!
stupid
The
FTDIs.
chips,
Yes,
yeah.
I still have probably another.
And this is the old FTDI chip where you had to
So
put separate
you know
crystal.
one
Yeah.
secret.
Oh, it's horrible.
You know one secret.
What?
The design of the circuit that surrounds the FTDI chip.
Yeah.
I copied from one of your boards, Limor.
There's mine. Why is my name not on here? I'm the 5th name. Okay, you can write down the 4 original names and then add my name. Yeah, this is I actually have my original FTDI helper board.
It's the only thing I did.
People are guessing the current, some of the current.
No,
folks.
this is a toughie.
Yeah.
The
Can we give
4
names?
No,
No, okay.
because this is a big prize.
Oh, fair enough. Okay.
So find an original Arduino or a picture of an original
there
3NG.
is one name that's.
That'll be hard to find.
There's one name added and one name missing.
Yeah.
That one name added, by the way. Okay, this is going to be a hint, and I promise it won't
All
be a
right,
good
that's
hint.
fine.
The one name that's
Oh,
on there
someone got
that
it.
I won't
Oh.
know is the person that redesigned the icons for 1.0.
Okay.
Okay.
That was obscure enough.
We have a winner. JMSAV.
I could have asked also the URL because I could have
Yeah.
Arduino.berlioz.de.
Exactly.
They'd be like Arduino.cc. Like,
You know,
nah.
because I tried to register Arduino at SourceForge.
Yeah.
But they were being.
Okay,
annoying.
so read out the names. Can you read out there? We
Okay.
have a winner.
The name
JM
is
Adverda.
M.
One.
Banzi, D. Cortiles, D. Cortiez, Cortiez, D. Melis, and the 5th Arduino member, and Zambetti.
Nick Zambetti, yep.
Yeah, Nicola Stambetti, who now works at Apple.
All right. I bet you know what? There's probably a little bit of Arduino making its way into Apple now because Google has the ADK.
Yeah,
They have
actually,
some people.
one of the moments we were happiest about recently was when we found an Apple job posting that asked for Arduino skills.
Wow.
Yeah.
God knows what they're making.
Blinking LEDs.
I'm waiting for the Arduino
Well,
to come out.
Google, their biggest competitor with the Android, has the ADK, so it's time to probably start thinking about how you can get an iPhone or an iPad to start working with accessories in an easy way.
Actually,
We'll
something
see.
started to happen.
Unfortunately, Apple has a policy against all this open source stuff related to the accessories. So
Yeah.
that's a pity.
Yeah, we have to reverse engineer their charging scheme every time they come out with a new product because of the Minty Boost.
Sure.
So every single time we do a video.
Cute.
Yeah.
Okay, you grab Boss
All right.
Cat.
So you guys keep talking.
All right.
We're gonna do some more chatting.
Yeah.
So, this Dewey, what are the cool peripherals that made you pick this chip? Why this chip?
Well,
Does it have like Ethernet? Does it have like 18 SPI ports? What's the killer thing?
there was a request from the community that many people discussed the fact that they would like to see an Arduino running on an ARM chip.
Yeah.
So since we had a relationship with Atmel already, and so we looked at so they had a pretty successful line with the SAM7 microcontroller. So then I went to, also the nice thing is that the ARM processor in Atmel are dealt with by Atmel France in the south of France.
Which is
So
near
it's,
the factory.
well, also it's nice to go to the south of France, to go to Provence, and not to go to some place in the middle of nowhere. So,
Okay,
we just got this bow tie or this.
All right, let's show off Boss Cat. Okay.
Yeah.
So this is Boss Cat.
Yeah.
See if you can see the bow tie.
Yeah. You can
Nice.
see
The
them.
tie he's got on.
so it's the only cat with a bow tie.
Yeah.
He's got a
A,
little tie.
a lot of parents watch the Ask an Engineer show, and their kids watch it too. And the kids now demand, "Where's the cat?" Because they think it's a cat show. Like the rest of the internet
The
right now.
question is, how do you get the cat to keep the bow tie on?
He does.
Kitty cat.
With a lot of training.
Is a neat guy.
Hello.
Oh.
All right.
So,
Okay,
but
Boss Cat.
in general, we had a meeting with Atmel and we looked at the roadmap and we picked this one because it was powerful and lots of platforms and a lot of peripherals. And also, we saw the roadmap, which I cannot talk about because it's under NDA. But there are some cool devices coming after this one with native support for Ethernet and some ridiculously large flash space and
Lots of RAM.
lots
That's
of
cool.
RAM.
Did they tell you if there's going to be something after the 328? Is there going to be a chip after that, or is that going to end the line?
So, when I had the meeting in Norway, I felt for a second I was the union representative for the makers. Because I was demanding all these answers like we want more powerful chips in deep package, and they say that basically obviously the deep package is becoming less and less important because people don't make through-hole parts anymore, but they're going to keep it because of the prototyping. Like a lot of people want through-hole to prototype, so the 328 is not going to disappear. But I wouldn't expect like major, like completely new stuff running on that particular form factor.
Yeah.
They might, and also they say that the size of the chip depends a lot on the RAM and the flash, and they sort of get to the point where they can't make it bigger in that particular form factor. So I would say that it's a general trend in the industry to go SMD, and unfortunately a lot of people, they like the fact that Arduino has a through-hole chip that you can remove. But I don't think you'll see a lot of exciting devices come out with that form factor.
Okay. Well, thank you so much for coming out tonight. I know it's late.
You will.
Yeah, it's fantastic. Thank you for answering all those questions. And thank you for doing the Arduino project. I think this is one of the biggest things to happen for artists, for technologists. You guys are inspiration. You're heroes to us. I'm so glad you can come out here and you can hang out with the cat.
Thank you for making it possible.
You have supported this from the beginning. Phil was writing about it, and also we got a lot of inspiration from Limor because I was looking at her website before there was Arduino and anything. So
the leading library maker, I think.
Yeah,
25 libraries.
Yeah.
Just throwing it out there. Who can beat 25 libraries?
I have 5 more that are not even they're private because they're still under.
And probably 3 that you wrote yesterday.
Under NDA.
No, because I don't. They're in GitHub, but I don't public them because they're not finished. So people like download them. They're like, it doesn't work. I'm like, I know it doesn't work. I'm working on it. But
all right,
they'll
and
be,
here
publicized.
is your moment of Zener. Yeah, but
Oh my God.
you got a little Zener diet.
Zener.
Yeah.
Instead of your moment of Zen, we have a moment of Zener.
Ah.